Does life ever seem too complicated? Well, sometimes with math problems, the first step is to simplify. So let's take a look. These are ones we did in class. And here we go. Okay, so yeah, the first thing we need to do with this is simplify the expressions on both sides. We want to isolate the x, that's our whole point. But on this left side, we see 4x plus 5 in parentheses. You can't do anything with that. You cannot combine 4x with 5. They are not like terms. So you can't do anything there, but you can go ahead and distribute. Multiply 4 times that whole quantity. So you get 16x plus 20. We'll do the same thing on the other side. 15 plus 6x. Okay, so now we're to the point we want to get all the x's on one side and the numbers on the other, right? So it's reasonable to subtract 6x from both sides. That way our x term will stay positive. Okay, so what's that give us? On the left, 16x minus 6x. 10x plus 20. On the right, 6x minus 6x is 0, just like we wanted it to be. So we do not have any x's left on the right. That's good. Okay, so now we have our x's on the left. We're going to have to get 20 out of there, right? So we can isolate the x, subtract 20 from both sides. Okay, and that gives us on the left 10x, just like we wanted. On the right, 15 minus 20, negative 5. Okay, so now we're going to divide both sides by 10, right? To isolate the x. I'm going to go back. I want to leave that black. I'm going to rewrite it before we divide. And write in the 10 that we're dividing by. And so that gives us x equals, so what's negative 5 over 10? We need to reduce that, right? You can't just leave it negative 5 over 10 to get full credit, and that reduces to negative 1/2. Okay. So let's check that. We're going to plug negative 1/2 in. A little bit tedious, but let's get it done. 4 times negative 1/2. I'm just putting in negative 1/2 everywhere there's an x. Okay, let's plug and chug, see if it's right. 4 times negative 1/2, negative 2. 2 times negative 1/2, negative 1. Okay, the tedious part with the fractions is done. Hopefully the rest will work out. Negative 2 plus 5 is 3. 5 plus negative 1 in the parentheses, that is 4. 4 times 3, 12. 3 times 4, 12. Excellent. It checks out. Okay, so let's look at the next one. Again, there's some work to do to simplify this before we start solving it, you might say. You see a problem like this, what do you have to do first? You want to get x by itself, but when you look on the left, you got 9x, you've got another x term there, negative x. So yeah, you've got to combine those like terms, okay? You see that kind of problem you have to combine. So the 9x and the negative x we're going to combine. That's 9x minus x. That's 8x. We've still got the 2. We won't do anything with it right now. And then that makes it like a normal problem. It's like this one was after the first simplification step. So we will get the x's by itself. Subtract 8x from both sides. Minus, oh, we want red. Minus 8x, minus 8x. Okay. On the left, we just have 2. On the right, we just have 4. Okay. That doesn't look helpful, but actually it is helpful. We're done. What does it mean? We got 2 equals 4. That's not true. 2 does not equal 4. But remember that the steps we're doing give us equivalent equations all the way down the line. So that equivalent means they have the same solutions. All values of x that make any of these equations true are the exact same value of x that make them all true. Okay? I'll say that again. The value of x that makes specifically this last one true is the same value of x that makes the others true, including our original equation. Okay, so what value of x makes this final equation that we got true? Can you think of any x that's ever going to make that true? No. Doesn't matter what you make x, that final equation is not true. What that means is, since there aren't any values of x that make it true, guess what? There aren't any values of x that make the original equation true either, because they have the same solution set. The solution set is the empty set. If you are talking in set terms, set terminology, the set of solutions is the empty set. Okay, and not to beat a dead horse, but this is an important concept. The solution set is the same for all of them. Solution set for the final one is the empty set. That means the solution set for the first one is. So that's our answer, and you can write that this way. That means the empty set. You could also just write down the words empty set. And you could also write it this way, no solutions. I'm not going to be picky which way you want to write it. So say that, or, okay, you can write it any of those ways. Okay. Interestingly, this one is hard to check. You just have to go back and check your work and make sure you didn't make a mistake. Because the way to prove this is wrong would be to plug in a value for x that worked, and you don't even know what to try. Because our work so far says, hey, there's nothing that makes it true. And so we don't really have anything to plug in to try. So yeah, just go back and to check it, you have to check your work, check every step, make sure you made no mistakes. 9x minus x is 8x, looks good. Subtract 8x from both sides, you get 2 equals 4. Okay. Let's write our box around this one, forgot to do that. So we got one more. Okay, again, first thing, we've got to do some math on this. We've got to simplify these expressions, at least the left. We have our variable is b, and we have 8 plus 6b in the parentheses. So what do we do with this? 8 plus 6b as a quantity, in parentheses, is subtracted from 1. That means the entire quantity is subtracted, not just the 8. You're not subtracting just 8, we're subtracting 8 plus 6b. And so you can think of it that way. The subtraction sign applies to the whole thing, and so you could call that distributing the subtraction sign. So that's 1 minus 8 and then minus 6b equals negative 5 minus 5b. Okay, distribute the subtraction sign through. And another way to think of it is that you actually have a negative 1 times what's in parentheses. It's another way to think of it. You would distribute through that negative 1, multiply both terms in the parentheses by negative 1. Okay, so we're ready to, are we ready to go ahead and do the steps to solve, or is there more simplification? Okay, we have 1 minus 8. Well, those are just both numbers. We can combine those. Those are like terms. So you got to combine all the like terms to get it to a state where you're ready to solve it. So 1 minus 8. Okay, that's negative 7, right? Minus 6b, negative 5, minus 5b. I think we're now ready, get this out of the way, to solve this. So, got to get the 6b by itself. We have negative 6b here, and we have negative 5b here. So, which way should we go? Which side do we want to get our b's on? And you can do it either way. But if you think ahead, we'd rather have b to be positive, and we're going to be adding because we're subtracting 6b, we're subtracting 5b. So we're going to be adding to both sides. Which way would add a big enough number to make it turn out positive? Well, if we add the 6b to both sides, then we'll have a positive b. But if you do it the other way, it'll still work. So let's go ahead. Let's add 6b to both sides. Okay. On the left, negative 6b plus 6b, just like we wanted. That adds to 0. So all the b's are gone. So you got negative 7. On the right, we still have our negative 5. And you take negative 5b plus 6b, that is 1b, or just b. And it's positive, which makes everything a little easier. We'll divide. I'm sorry, now we want to get b by itself, so we have to get rid of the negative 5. So we just add a positive 5, right, to both sides. Negative 7 plus 5 is negative 2. Okay, negative 5 plus 5 is 0, so that goes away and only leaves the b, and we have it. If we had turned out with a negative b at the end, we could, you know, at that point, divide both sides by negative 1, we would say, or multiply both sides by negative 1. Doesn't matter. You would have to do that to make b positive. We don't have to do that. We're done. And we have b equals negative 2. We'll plug that in. And make sure it's right. 1 minus 8 plus 6 times b, which is negative 2, equals negative 5 minus 5b. Oh, sorry, not 5b. We're going to plug it in. Minus 5 times b, which is negative 2. Okay. Let's do this math inside. 8 plus 6 times negative 2, negative 12. Negative 5 times, negative 5 times, oh, well, sorry, back up here a little bit. Negative 5 minus 5 times negative 2. Okay, here's the negative signs all over the place. Got to be careful. This is negative 5 times negative 2, right? So or you could think of it as subtracting negative 10. Let's go ahead and write that down. We won't do two steps at once this time. It's still minus. We just brought the minus sign down. 5 times negative 2 is negative 10. Okay. So we have 1 minus 8 plus negative 12 is negative 4. Negative 5 minus a negative 10. Well, that becomes plus 10, right? 1 minus negative 4. Well, that means 1 plus 4. I'll go ahead and write that down. On this side, 1 plus 4 is 5. Negative 5 plus 10 is 5. And that checks. So that's tedious. In real life, when you're doing a quiz or something, and if you're limited on time, you wouldn't have to write all these steps down, of course. You do some of this in your head. Yeah, negative 5 minus 10, yeah, that's going to be, it's going to be 5. So you can write down as much as you need to and as much as you have time to, but it's good to check them if you have time. Okay. And we won't always check them in class and on the videos, but I like to emphasize it's really a good thing to do. Make sure you get them right on the tests or quizzes. Okay, so that's it for that problem set. If you have any questions, make sure you bring your questions to class. And that's all for now.